Okay, so we're back talking about parallel and perpendicular lines. And you might wonder why we're talking about those in an algebra class, not a geometry class, because geometry is where we often talk about those things. But here we're talking about them in the context of how the equations of lines compare if those two lines are parallel or those two lines are perpendicular. So there are two things you have to remember, okay? The only thing we care about with parallel and perpendicular lines in this class is their slope. So the first thing you need to remember is that parallel lines have the same slope, which makes sense. If you think about slope as how steep they are, two lines that are parallel are going to be the same steepness. If this one's much steeper, it would run into it, right? Or vice versa. So parallel lines have exactly the same slope. So if you know the slope of one line, you know the slope of any other line that's parallel to that. Okay, perpendicular lines, which are lines that make a 90-degree angle, right, like a T. Perpendicular lines have slopes that are what we call negative reciprocals. Okay, so reciprocal is when I flip a fraction. And negative reciprocals means that if it's positive, then the negative reciprocal is negative, or if it's negative, then it's going to be positive. So, for example, if you look on the bottom of this page here, if these two lines are perpendicular, we can see that the slopes are negative reciprocals. Here the slope is 3, or we can write that as 3 over 1, positive 3 over 1. This slope is negative 1 over 3. So the sign changed and it flipped. So those are the only two things we care about. If I say these two lines are perpendicular, we're just using that information to figure out the slope. If I know the slope of one, I can figure out the slope of the other. If I say two lines are parallel, then if I know the slope of one, I can figure out the slope of another. Okay? So that's all we're going to do to use this. The only way we're going to use this information. So if you think back to what we just did, if we were given 2 points and we're trying to find that equation, we used those 2 points to get the slope. Well, here we're just using different information to get the slope. That information is the slope of another line that's either parallel or perpendicular. So we can have lines that are parallel, right, that go the same way. We can have lines that are perpendicular that cross and form a right angle, or we can have ones that don't do either, right? These are not parallel, they cross, but they don't make a right angle. In that case, their slopes are just going to be different, but not negative reciprocals. So you can see I have some examples here, and you'll see some in the homework of, deciding whether these two lines are parallel, perpendicular, or neither. So what you need to do, put them into slope-intercept form, find the slope. In this case, they're not the same, and they're not negative reciprocals. They have opposite signs, but to be negative reciprocals, this would be 1 over 8, not 1 over 4. Okay, so again, same idea here. You're finding the slope. I'll let you try that. Okay, so when we're trying to do this, again, the only thing we care about with parallel or perpendicular lines is the slope. So often what I do is I set up my work using these kind of headings that you'll see here and that I have on the whiteboard behind me. So I'm going to do example 25, really start it, and I'm going to do it up on the whiteboard. All right, so let me just get to that page in my packet here so I have it in front of me. So we're trying to find the equation of a line that passes through the point -2, -3, and is parallel to y equals 3x plus 5. Okay, so this is the information we're given. So if you want to think about visually what this means, it means that we have a line. We already know a line that's y equals 3x plus 5. So if I think about what I know about that, it's y-intercept is 5, slope is 3 or 3 over 1. So rise over run, up 3, down 1, or sorry, up 3, right 1, down 3, left 1. Here's this line, y equals 3x plus 5. I'm looking for the equation of a different line, a line that goes through -2, -3, but is parallel to this one. So if this is this line, I should have used a ruler to draw that a little nicer, but I want to know the equation of the line that roughly is going to look like this, right? It's going to go through this point and is parallel to this one. So again, this is not what you'd be given, but that's what you can picture in your head or draw out on your paper. Okay, so I'm going to start out, what's my given line? The line that I am given information about in order to draw my own line. The given line is y equals 3x plus 5. In this case, we're lucky because it's given in slope-intercept form. So what's the slope of this line? Well, we know that the slope is this m, right? Whatever's in front of the x. So my slope of my given line is 3. All right, now I'm trying to write the equation of a new line that's parallel to this one. So if I know the slope of this line is 3, and I want to write, I'm working towards writing the equation of a line that has a parallel slope, well, we know that the slopes are going to be the same again, right? Because we know that the slope of two parallel lines has to be the same. Now I want to write the equation of this new line. Well, I'm just going to always start out, when I'm writing an equation, I like to always start out by writing y equals mx plus b at the top of my work, just to remind myself. So what do I know? Well, I know that my slope has to be 3. And I know that I still need to get a number for b. Well, think back to what we did before. Once we have slope, no matter how we get it, whether we get it from a given line or whether we get it from 2 points, once I have slope, I can plug in x and y and solve for b. I have an x and a y. That's my point. So I plug in -3 for y and -2 for x. Then the only unknown I have is b. So now I can go ahead and solve for b. b equals 3. So y equals 3x plus 3. Okay, you see my drawing isn't super accurate, right? It would go up a little steeper, but okay, so anytime you are asked to find the equation of a line that's parallel or perpendicular to a given line, you can use this same idea, right? We write out our given line. Now, sometimes our given line is not given in slope-intercept form already. So if I have something, 3x minus 2y equals 8, in this step here, I can start out with that and solve till I get down to slope-intercept form. Then from there, I just read off my slope. Now, the slope of the new line, you have 2 choices. If you're looking for a line that's parallel to this one, it's going to be the same slope. If you're looking for a line that's perpendicular to this one, then your slope is going to be the negative reciprocal. Okay, so if my slope were 3 here, and I wanted the negative reciprocal, it would be -1/3 in this case. Whatever your slope is here, it goes in for m. Your point that you're given goes in for x and y. We solve for b. Okay, so that's the only reason we care about parallel and perpendicular lines in algebra. If you look at number 27 on this page, so 26 is very similar, it's a perpendicular line. 27 says find the equation of a line that's perpendicular to the line y equals 2. Well, think about that kind of line. Y equals 2 is a horizontal line going through 2. If you think about it, every point on this line has a y value of 2. This one is 1, 2. This one is 2, 2. This one is 3, 2, right? Y is always 2. If we want to find a line that's perpendicular to this, that's going to be a horizontal line. And it goes through the point 3, 5. So 3, 5 is right here. If it goes through that point, here's my line, every single one of the points on this line, no matter where it is, has an x value of 3. X equals 3 is my equation. I know it's kind of small up on the whiteboard, but you have the same thing here. All right, so that's what I wanted to talk to you about with parallel and perpendicular lines. And as far as the other two sections in Module A, I think the notes are a little more self-explanatory about those, but again, if you have questions, please email me, send me a message through Lumen, or jump on Zoom. All right, thanks guys.